First of all, we need to construct the table. The table will equal to 1. Why? Because the probability must be equals to 1. So C times with the x plus y. x0, y1. x1, y2, and so on. Then we times, we get 27C equals to 1. So C automatically equals to 1 over 27. Then we substitute C with 1 over 27 to the equation of C in bracket x plus y. Then we substitute the number of x and the number of y. Then we get the value like in the table. So for question B, find the marginal distribution of x. We sum the joint probabilities across all values of y for each value of x. And for the marginal distribution of y, we sum the joint probabilities across all value of x for each value of y. These give us fx x and fy y, which are the marginal distribution of x and y. For question C, we need to check whether x and y are independent. We must compare the joint probability fxy with the product of marginal fxy and fxx. When we substitute the values, we can see that fxy are not equal to fxx, fyy. So x and y are not independent. For question D, this is the probability with condition. We must, it's given x equals to 2 and y less than 3. So we need to derive and make it like the below. Y less than 3 intersect with x equals to 2 and divide with x equals to 2. Then we just substitute the values. Then we got the answer like below. For variance x and variance of y, we need to find the ex first. To find the ex, x times the equation given. And then we plus them all, and then we get the ex. For the ex squared, we squared the x, while the we squared the x. So we need to do for each x and y, and then we will get the ex and also ex squared and ey and also ey squared. And then we substitute to the equation of variance for x and also y. When we get the variance of x and y, we substitute the variance equation into the equation given, which is e in the bracket of 4x squared plus 6y minus 2. And then we substitute, and then we get the answer.
My name is Kari. Today I'll be explaining about question 2. So for the first part, for the first question is A. We need to find the value of k. So to do this, we use the basic formula of joint probability density function, which states that the probability over the entire region must be equal to 1. So I integrated the joint density function using the given limits of x and y, and after completing the integration and simplifying the result, we equal it to 1, and then we find k, and then we obtain the k. And then for part B, we need to find the marginal density function. So to find the marginal density function of x, we need to integrate the joint density function with respect to y with given limit, which is 0 to 2. And to find the marginal density function of y, we need to integrate the joint density function with respect to x with given limit 0 to 1. And then when you solve it, you will get the answer, just like my answer. For part C, we need to determine whether x and y are independent. So to check this, I compared the joint density function with the actual value of the marginal density function. And since, as you can see, it is impossible to compare, I concluded that x and y are not independent, because we can't compare both because it's not the same. Okay, so for question D, first we need to find the mean of x and y. So we need to integrate the function, and for x we need to times it with x and use the limit, which is 0 to 1, And then for min of y, we need to times the function with y and then integrate it with limit from 0 to 2. And then when you get the answer, we use the given formula to find the e. So for the next step, we need to find the variance of x and the variance of y. And to find the variance of x and y, we need to find ex squared first and ey squared. So it's basically the same thing like we did with ex and ey, but we switch the x and y with x squared and y squared, just like I did. And then we solve it like normal, integrate with the limit given, and then we will get the answer. And we use the variance formula, which is for variance of x is ex squared minus ex squared, and for variance of y, ey squared minus ey squared. So for the final answer, we will get variance of x, which is 73 over 1620, and for variance of y, we will get 26 over 81. So for the next step is we want to find the covariance of x and y. So the first step to finding the covariance is, first we need to integrate the inner integral and the outer integral of function of f, x and y. And then when you get the answer, the final answer after you simplify it, using my answer is 43 over 54, you will use the formula which is exy minus ex times ey. That I get 43 over 54 minus 13 over 18 times 10 over 9. And for the final step, to find the variance of p. So I've listed the variance formula, and we compare it with the given formula, and we will get the a, b and c. And then we just need to substitute it with the value that we have, and then we will get 71 over 15. That's all.